we want to talk about functional groups, and homologous series, right? So we can say a homologous series, it can be represented by a general formula. It can be represented by what? By a general formula, right? So we want to start talking about alkanes, right? So alkanes, let's try to draw the structure of the functional groups, right? You know that the name ending with what? With A-N-E. It ends with A-N-E. So we want to draw the structure of alkanes, right? So alkanes, let's talk of an example of ethane. Right? Ethane, we are saying it has got two carbon atoms, right? And then these carbon atoms, now they are bonded. The first one is bonded to 3 hydrogen atoms, and the other one is also bonded to 3 hydrogen atoms. That is ethane, that ends with A-N-E, right? So we are saying the molecular formula, right? The molecular formula of ethane is now going to be, these are C2. It's C2. And then you see the hydrogen is 1, 2, 3, 4, 5, 6. The hydrogen is 6. Right. So we are talking of the homologous series is an alkane. Right. Homologous series is an alkane. Right. And we are saying we are representing ethane. It ends with A-N-E. Right. And this is the what? The structural formula. Right. Or the structure of the functional group. Right. So we are saying it's usually, we are saying this is C2, and then the hydrogen we are saying is what? It's 6. Right. And then from there, let's try to talk about now alkanes. So you see, alkanes, they've got a single bond. They've got a what? A single bond. Right. You can see from the example of what we did. Right. And then we want to talk about now alkenes. That is another homologous series. Another homologous series. Alkenes. Alkenes now, they've got a double bond. You see, they've got a what? A double bond. The carbon and the carbon. You see? Right. And they end up with E-N-E. They end up with what? E-N-E. That is what? That is the alkenes. They end up with E-N-E. Right. So we can talk also of, on the alkanes, we gave an example of ethane. And then on the alkenes, we can also give an example of ethane. Right? Ethane. Right? So we are saying, if we are to draw, we are saying it has got what? A double bond. That is the structure of the functional group of alkenes. The structure of the, so this is an example. Ethane is an EG, is an example of an alkene. And then we are saying the structure, right? They will be having a double bond, and this carbon can now chain maybe to other, it can now chain to hydrogen atoms, right? So ethane, it can have a formula of CH2, right? So you can see we are saying it's C2H4, right? This hydrogen, they are now what? They are now 4, right? So you see, you can see now the general formula is CnH2n, right? Because you see, when you have got 2 carbon atoms, they are bonded to 4. So you see, the next one is now going to say, if the carbon is what? 3, it's going to be 6. Right. And then if the carbons are what? 4, hydrogen is going to be what? 8. That is the structural. That is the structural formula of what? Of the whole molecule of the alkenes. The structural formula, right, or the general formula is CnH2n. And then for the alkanes, it's what? You see, we are saying it's C2H6. So it means we are going to say Cn. If it is N, so now the hydrogen should be 2N, right? 2N plus 2. That is now the general formula of alkanes, right? So I want you to understand these things. How do they actually go? So you have to know we are talking of the homologous series, right? The structure of the functional group, you see, right after the structure, the name ending with ANE. And then the other one, it has got an N ending with what? ENE, right? And then from there, we want to talk of what we call alkenes. These ones, they've got a triple bond, right? They've got the carbon atom has got a triple bond, right? We are saying alkanes, right? Al is not alkenes, it's alkynes, right? Al with an ALK, and then the name is now ending with YNE. That's the name ending, right? We can talk of ethane, you see, right? Ethane, it has got CHCH. You see, there is a triple bond, right? So you could see like we've got the same numbers of the carbon atoms, there are 2. The hydrogen atoms, they are what? They are 2, right? When we are dealing with what? Ethane, right? This one is an alkanes, right? And then we can talk of alkyl halides. We can also talk of what? Alkyl, right? Alkyl halides, right? Where we are saying X can be fluorine, chlorine, bromine, iodine. We can talk of chloromethane. Chloromethane is because we are saying it's CH3, right? Cl. So chloromethane is an alkyl halides. The halides, this halide can be fluorine, chlorine, or bromine, right? And then from there, let's now talk of alcohols. Right, so you have to be also familiar with what? With alcohols. So you could actually see now alcohols, there is now an introduction of OH bond now. You understand? When we are dealing with alcohol, so let's start maybe with ethanol. I want you now to understand the structure now of what? Of alcohol. Alcohol, it ends up with OL, right? That's the name ending, right? So we can say for ethanol, it can be CH3, and then there is O, CH3. You understand? There is now this atom of oxygen, right? There is an OH at the ending, right, of the condensed structural formula. You see, we are saying when we are dealing with what? With we are saying CH3, right? And then we are, let's say CH3, let's CH3 CH2, CH3 CH2, and then let's put OH for ethanol. CH3 CH2 and then OH. So we are saying we've got 1, right? And then we've got 2. And then the oxygen, you put it at the end. So we've got 1, 2. So you discover that we've got how many? 2 for carbon, right? So we are saying CH3, CH2, CH3, CH2, CH3, CH2, OH. So we are saying we've got 2 here for carbon, right? And then for hydrogen, it's now 3 plus 2, 5 plus 1, 6, right? And then oxygen is 1. You see the formula for alcohol, right? this is an example of ethanol. This is the molecular formula for ethanol, right? So there is an OH after, right, the other what? Chains, right? And then let's now also talk of ketones. Ketones, right? This is another interesting one, right? Ketones. Let's think of a ketone can have this structure of the functional group. We can say we can have 3 carbons, right? And then the carbon can be double bonded now to the what? To the oxygen. It ends up with ONE, with 1. We can talk of an example of let's talk of propanone. Propanone. It's an example of what? Of ketone. So we are saying propanone. Propanone. Let's talk of propanone. Propanone. Right. So we are saying propanone, it's CH3CO. Right? We are saying CO and then CH3. So you could see that how many carbon atoms is 1, 2, 3. And then how many hydrogen atoms is 3 plus 3, 6. And then the oxygen, we are saying there is only 1. So this is how you represent propanone, an example of a ketone. And then we can also talk of aldehydes. 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 Right. So you have to know the structure of the functional group. The structure of the functional group is the one that you should be able to what? To draw first. The structure of the functional group. Right. So we want to draw the structure of the functional group. So this carbon, right? We have got on the aldehydes, we have got 2, right? Carbons, right? And these 2 carbons, they can form a double bond with what? With oxygen. And they end up with aldehydes, they end up with Al, right? We can talk of an example of ethanol. Ethanol, right? The structural, condensed structural formula for ethanol, we say CH3CHO. Right, so you see the carbon atoms, there are 2. The hydrogen atoms, we are saying for ethanol, the hydrogen, there are 4, right? 4 hydrogen, and then there is 2 oxygen, right? For ethanol. Ethanol, okay, the oxygen. So we are saying ethanol, it's CH3CHO. Right? So we are saying the hydrogen is 4 and the oxygen is 1. Right? And then from there, we can now talk of carboxylic acids. Carboxylic acids. Carboxylic acids. So again, the structure of the functional group of carboxylic acids, you can think the oxygen can form its bond, and then we've got 2 oxygen atoms, a hydrogen atom, and the carbon again, it can form a double bond with oxygen. Right. And you see the end with ends, the name ending with OIC. We can think of an example of ethanoic acid. Ethanoic acid. So ethanoic acid, the structural formula is CH3C double, right, 2 oxygen atoms. So you could see that there is 1, or when we are saying we've got 1, 2 carbon, and then hydrogen is 4, and then the oxygen is what? Is 2. And again, we can talk of esters and arenes, right? Esters like ethyl, ethanoate, right? There are also other homologous series that you're expected to know. So this is how you know homologous and functional groups, and it's very, very important to master this. So again, we can talk of esters, right? Or we can say esters, they've got a pleasant smell, right? So we are saying they can have a structural formula, or the structure of the functional group. It has got a double bond with oxygen, and you see these are carbon atoms. Again, they can also bond with oxygen, just like carboxylic acids, and also with what? Hydrogen. You see, so that is, and the esters, the end, they are named with OAT. We can talk of ethyl ethanoate. It's an example of an ester with a formula CH3C, and then we are saying the oxygen is 2 oxygen atoms, and then we are saying C2H5. So you can see that how many carbon atoms? 1, 2, 3, 4, right? And then the hydrogen atoms, how many are they? Let's count them. 3 plus 5 is what? It's 8. And then how many oxygen atoms? We are saying 1, 2 is for ethyl ethanoate, right? And then the arenes. Arenes is another interesting homologous series. So you can see the structure of the arene. They are going to be like this. You see, it's a carbon, you know, like what you say in organic chemistry. They form chains. You know, that's why even they are used in the manufacturing of paints, plastics, you see. So we are trying to draw the structure of an arene. And then you see this, all these carbon atoms can now bond to other what? Atom. We can talk of an example. Let's think of benzene. Benzene is an example of an arene, and they are aromatic, right? So benzene, we can talk of C6, right? H6. You understand? 6 carbon atoms and 6 hydrogen atoms, right? So that's something that you have to know in what? Homologous series and functional groups.